Hello everyone. Today I'm going to discuss the very basics of chemistry. And by that I'm going to start going over the basic construction of ions. Yay, ions. But before we get into the nomenclature, I just want to do a few very basic examples. So we're going to start off with the classic NaCl. So then the question is does this combine? How does it combine? How does this work? Well, we're going to start off by scrolling down to my wonderful handy-dandy periodic table. Now, Na, or sodium, is located right here in the periodic table, and then we have Cl located over here. Now, when you look at the periodic table, it is quite important to understand that over here we have the cations, which always have positive charges, and over here we have the negative ions, which are always called anions. The way I always remember it, our cats are cute, therefore they are positive. So then the cation is positive. Then the anion, well, if anything starts with an, then it is always negative. So then, enough with that. Let's just start by breaking down their individual charges. It is related to their periodic numbers. So we have +1 is here, +2, +3, and then this one can be plus or minus 4, -3, -2, -1, and this one is 0 because it's the noble gases. And so what we simply do to create an ion is we take something with a positive charge and combine it with something with a negative charge. This is a very basic idea. And so what I chose was Na, which as you can see has a +1 charge, and Cl, which has a -1 charge. So +1 -1 is equal to 0. When we get a 0 charge, then that means the molecule worked. So we have a +1 and we have a -1. And so then what we're going to carry on to do is try something where the charges are slightly different. Let's try magnesium and let's try fluorine, or magnesium fluoride. So we have Mg, which has a 2+ charge, and fluorine, which has a 1- charge. So what we're going to simply do is take this number and put it down here, and this number and put it down here. The reason for that is then we get MgF2, and then since Mg has a +2 and fluorine has a -1, and then that is multiplied by 2, we then have 2 minus 2, which equals 0. This molecule looks good. Now I want to try something else. Let's take a look at, I'm feeling up to calcium oxide. So calcium, as you can see, has a +2 charge. Oxygen has a -2 charge. So if we go up here and write calcium, yep, I did choose oxygen, calcium oxide, we have a 2+ and a 2-. So cross the charges. So we put that there and we put that there. We have Ca2O2. Now the next rule I'm going to talk about is that when you have all of your molecules with numbers underneath them, what you want to do is get to the lowest common denominator. And a common denominator you should have learned way back in math class. So a common denominator between these two, well, if you have 2 and 2, you can simply divide it all by 2. Get these 2's out of here, so it is just calcium oxide. And calcium has the 2+, oxygen has the 2-. 2 minus 2 equals 0, smiley face. And so that seems simple enough, right? And now what I'm going to do is try one more with you. Well, I feel like doing some aluminum, which is located right here, and I'm going to do oxygen, so aluminum oxide. So we have aluminum, which has the 3+ charge, and oxygen, which has the 2- charge. We cross the charges, Al2O3, aluminum oxide. Beautiful, right? Now I'm going to quickly explain the nomenclature of these ions. So what you always do is you start with the cation. And if you remember, the cation is the positively charged one, and the anion is always the negatively charged one. So a good example would be, for instance, sodium chlorine. It's not called sodium chlorine. That name is wrong. Instead, we call it sodium chloride. This "ide" at the end is swapped out for the "ine." So another example would be with fluorine. Say if we had sodium fluoride, it would be, well, instead of sodium fluorine, it'd be sodium fluoride. And then, say if you were to have sodium and oxygen, that's NaO, and it would be 2 because you cross the charges, because oxygen has a -2 charge. You have this beautiful thing called sodium oxide rather than sodium oxygen. And that is the basic nomenclature of these ions, and we'll talk more about them in videos to come.